So dear students, so last class we seen major losses in pipes. So major losses mainly occurs due to friction. Okay. So now onwards we will see minor losses. Minor means a small amount of losses. Okay. So there are major losses only because of friction, but it is not like minor losses. It is not like major losses. There are different causes is there for minor losses occurs. Okay, let us see one by one in this chapter. The loss of head or energy due to friction on a pipe is known as the major losses. We already know. While the loss of energy due to change of velocity. Okay, this point is very very important. Change of velocity of the following flowing fluid in magnitude or direction is called minor losses of energy. The minor loss of energy or head includes the following cases. So these are all the different cases, okay, occurs due to the minor losses. First one, loss of weight due to sudden enlargement. Loss of weight due to sudden enlargement, and loss of weight due to sudden contraction. Okay, and loss of weight due to entrance of your pipe, a loss of weight at the exit of your pipe, loss of weight due to an obstruction in your pipe, and loss of weight due to bend in pipe, loss of weight in various pipe fittings. So these are all the causes for minor losses. So in this class, we will see one by one. Okay. So in case of long pipe, the above losses are small. In case of long pipe, okay. So a straight pipe having 1 kilometer or 2 kilometer, this type of losses is very small as compared to with the loss of weight due to friction, and hence they are called minor losses. Minor losses, and even may be neglected without serious error because due to it is very very negligible, very small amount of only. So sometimes it may be neglected. Okay, but in case of a short pipe, okay, these losses are comparable with the loss of it due to friction. Okay, so short pipe means a 1 meter pipe, 2 meter pipe, and it turns number of times, okay, in 90 degree, 45 degree, or some other angle, okay, frequently. Okay, suppose in case of in a house, in terrace we have a water tank. Okay, from the water tank only we get water from our kitchen tap, bathroom, or in a wash basin, in everywhere. Okay, so that it is not a straight line pipe. Okay, so there will be a 2 or 3 times 90-degree bends or occurs in every pipe. Okay, so without changing its direction we can't achieve the correct path of the pipe. So bends is necessary, okay, for the to change in the direction of the pipe. Okay, so in those type of pipes, this type of minor losses is occurs very much. Okay, so now let us see first loss of weight due to sudden enlargement. What is this meaning? Sudden enlargement means, suppose consider this is a pipe flow. This is a smaller diameter pipe, say 10 mm. This is a smaller diameter pipe. Okay, after some length, this smaller diameter is changed into a larger diameter. So suppose this is 20 mm. Okay, take it as 20 mm. Okay, so the diameter changes abruptly. Okay, from 20 mm, sorry, 10 mm to 20 mm. So it is called sudden enlargement. Okay, so consider a liquid flowing through a pipe which has sudden enlargement as shown in figure. Okay, consider two sections, 1 1 and 2 2, before and after the enlargement. So 1 1 means before the enlargement, 2 2 means after the enlargement. Okay, so P1 A1 is the pressure acting in this direction at 1 1, and P2 A2 is acting in this direction. Okay, so finally loss of weight due to sudden enlargement, HE. Okay, it is called HE, sudden loss of weight due to sudden enlargement. The enlargement first letter E, okay, mentioned as HE. B1 minus B2 the whole square divided by 2G. This is the formula for sudden enlargement. So V1 is the velocity before enlargement and V2 is the velocity after enlargement. Okay, so this is the formula for calculating minor losses due to sudden enlargement. So next, sudden contraction. Sudden contraction. Sudden contraction means it's quite opposite to sudden enlargement. So in sudden enlargements, the water or liquid flows from smaller diameter to larger diameter. But in case of sudden contraction, the water flows from larger diameter to smaller diameter. So it is called sudden contraction. So during this sudden contraction, you can see here, this is the larger diameter pipe. This is the larger diameter pipe and this is the smaller diameter pipe. So water flows like this. See the flow pattern. So after the sudden contraction at some place, that CC section is nothing but the diameter of the flow will get reduced. Okay, so that point is called vena contracta. That point is called vena contracta. Okay, so finally we got a formula V2 square divided by 2G. V2 square divided by 2G into Vc divided by V2 minus 1 the whole square. Okay, so this is the formula. So consider a liquid flowing in a pipe which has sudden contraction in area. Okay, as shown in figure. Considers two sections, 1 and 2 before and after contraction. So this is 1 is the before contraction and 2 is the after contraction. As the liquid flows from larger pipe to smaller pipe, the area of flow goes on decreasing and becomes minimum at section CC. So the area of flow is minimum at this point. That point is called vena contracta. So this section CC is called vena contracta. After section CC, a sudden enlargement. Okay. So after this, a sudden enlargement is occurs of the area takes place. The loss of it due to sudden contraction is actually due to sudden enlargement from vena contracta to smaller pipe. Okay. So up to this, that means from this point to vena contracta, sudden contraction occurs. From vena contracta to this section 2 to sudden enlargement is occurs. You can see here the direction enlargement is occurs. So finally, we got an answer V2 squared divided by 2G into Vc divided by V2 minus 1. Okay, this is the formula, the whole square. This is the formula. So now tell me what is V2? V2 is after the sudden contraction and V1 is the before sudden contraction and Vc. What is Vc? Velocity at this point. This is called Vc. Velocity at the vena contracta point. Okay, it is called Vc. Okay. So therefore, the final equation for head loss due to contraction is 0.5 V2 square divided by 2G. Okay, so memorize this formula only is enough for doing the solving the problem. So 0.5 V2 square divided by 2G. So this is the formula for sudden contraction. Okay, so now let us see the problem using sudden enlargement and sudden contraction. Okay, find the loss of weight when a pipe of diameter 200 mm is suddenly enlarged to a diameter of 400 mm. So initially the diameter 200 mm, after that it is enlarged into 400 mm. The rate of flow of water through the pipe is 250 liters per second. 250 liters per second. So how to calculate this loss of weight? Sudden enlargement. So for loss of weight, sudden enlargement, we know the formula. What is the formula? V1 minus V2 the whole square divided by 2G. V1 minus V2 the whole square divided by 2G. Okay. So now what is V1? What is V2? We don't know. Okay. G only we know 9.81. V1, V2, we don't know. So for that purpose only, they given the discharge. rate of flow. Okay, discharge. And also diameter 200 mm and 400 mm. Okay, so let us see diameter of the smaller pipe D1 200 mm. You must convert it into meter, 0.2 meter. Next, area. So A1 is equal to pi by 4 into D1 square. So D1 is 0.2. So we got an area 0.03141 meter square. Okay. Next, dia of larger pipe. D2 is equal to 400 mm. So if you convert it into meter means 0.4 meter. So therefore A2 is equal to pi by 4 into 0.4 square. Okay. So finally we got an answer 0.12564 meter square. Next, discharge Q is equal to 250 liters per second. If we convert it into meter cube per second means it is 0.25 meter cube per second. Okay. Next, velocity V1 is equal to Q divided by A1. So 0.25 divided by A1 0.03141 which is equal to 7.96 meter per second. Next, beta is equal to Q divided by A2. So 0.25 divided by 0.12564 which is equal to B2 1.99 meter per second. So you can see here the students, you can see here compare the velocity. So since at section 1.1 the diameter is 200 mm, but section 2.2 the diameter is 400 mm. So corresponding velocity at 1.1 the corresponding velocity is 7.96, but coming to B2 that means section 2 it is only 1.99. See the difference of velocity because of due to this diameter sudden enlargement. If diameter increases velocity decreases. That is the basic concept. Okay. So next, so since we found V1, V2, so loss of head due to enlargement is given by the equation H is equal to V1 minus V2 the whole square divided by 2G. So finally we got an answer 1.816 meter of water. So this is the answer. Okay. So these are all the simple question. Maybe they will ask 5 marks. Okay. So let us see the next problem. So this problem is the in 2002 JNTU question paper. From the question paper they asked. So let us see the problem. At a sudden enlargement of a water main from 240 mm to 480 mm, the hydraulic gradient rises by 10 mm. Estimate the rate of flow. So first understand the question. In a pipe, water is flowing. So at a particular point, the diameter of the pipe is increased. That means enlarged. 240 mm to 480 mm. That means double the times. Okay. The hydraulic gradient rises by 10 mm. What is meant by hydraulic gradient? So hydraulic gradient is nothing but it is a line which shows the summation of pressure head plus datum head. Okay, the summation of pressure head and datum head. Okay, is called hydraulic gradient. Estimate the rate of flow. So how to calculate rate of flow? What is the formula for calculating the rate of flow? It is nothing but velocity into area. Okay, so area we know, diameter given. So from that we can easily calculate the area. But velocity we don't know. So the first step is we have to calculate the velocity. Okay, so from the velocity we can easily calculate the rate of flow. So now you can see here, write the given data. So D1 240 mm which is equal to 0.24 meter. So area pi by 4 into D1 square. So pi by 4 into 0.24 square. Next D2 480 mm in meter it is 0.48. Okay, and A2 pi by 4 into 0.48 square. Okay, next rise of hydraulic gradient. You can see in the question the hydraulic gradient rises. It means the difference of two levels. Hydraulic gradient, two levels difference. So Z2 plus it is datum head plus pressure head. So hydraulic gradient is nothing but, don't forget, it is the summation of pressure gradient plus data gradient. Okay, so Z2 plus P2 by rho G minus P1 by rho G plus Z1, which is equal to 10 mm. Okay, so from that mm you must convert it into meters. Meters means 10 divided by 1000, 10 and 10 get cancelled. So finally 1 by 100 meter. This is the rise of hydraulic gradient in terms of meter. So next, let the rate of flow discharge equal to Q. So applying Bernoulli's equation on both sections, that is smaller pipe section and larger pipe section. Okay, P1 by rho G plus V1 square by 2G plus Z1, which is equal to P2 by rho G plus V2 square by 2G plus Z2 plus head loss due to enlargement. So we have to add that the head loss due to enlargement also. Okay, students. Okay, next, how to find the velocity. Now, what is the head loss due to enlargement formula? He is equal to V1, H is equal to V1 minus V2, the whole square divided by 2G. This is the formula. So from continuity equation, so we don't know V1, there are two parameters there. It is it is not possible to solve this problem. If you got two parameters, two unknowns. So we have to convert one unknown in terms of another one. Okay. So now from continuity equation, we have A1 V1 equal to A2 V2. So from this V1 is equal to A2 V2 divided by A1. Okay. V1 is equal to A2 V2 divided by A1. So that is the formula here I written, which is equal to, what is A2? Pi by 4 into D2 square into V2, we don't know, divided by pi by 4 into D1 square, which is equal to, so here pi by 4 get cancelled. So what is the other term? D2 square divided by D1 square into this V2. Okay, this V2. So what is D2? 0.48 with D1 0.24. This is the diameters of section 1 and section 2. The whole square into V2. Okay, so from this we got V1 is equal to 4V2. V1 is equal to, so here this is the V1 formula. So V1 is equal to 4V2. So substituting these values in the above equation, that means this equation. So substitute V2 in this equation. So 4 V1 is equal to 4V2. So in the place of V1, substitute 4V2. 4V2 minus V2 the whole square divided by 2G. So here also V2 is there, here also V2 is there. So 4V2 minus V2, 4 minus 1, 3, 3V2. The whole square divided by 2G, which is equal to 3 square is 9, V2 square divided by 2G. So now substitute H is equal to 9 V2 square by 2G and V1 is equal to 4 V2 in the previous Bernoulli's equation. Okay, so therefore P1 by rho G plus V1, instead of V1 you have to substitute 4 V2 square divided by 2G plus Z1, which is equal to P2 by rho G plus V2 square by 2G plus Z2 plus this value. That means this He, 9 V2 square by 2G. Okay, so now you have to simplify the above equation and rearranging the equation. That means P2 by rho G plus Z2 minus P1 by rho G plus Z1. So pressure we don't know, density we don't know, Z1, Z2 also don't know. So you have to rearrange. Finally, as per the hydraulic gradient formula, we know that it is 1 by 100. So substitute this value here. That means 16 V2 square by 2G minus V2 square by 2G minus 9 V2 square by 2G, which is equal to 1 divided by 100. So, which on simplification, we got this answer. 6 V2 square by 2G equal to 1 by 100. So, therefore, V2 is equal to root of 2 into 9.81 divided by 6 into 100, which is equal to 0.18 0.08 meter per second. This is the velocity at section 2. That means larger diameter pipe. Okay, velocity and a larger diameter pipe. Okay, so from that discharge is equal to Q is equal to. So once you know the V2 or V1, we can easily calculate as per continuity equation discharge formula A1 V1 or A2 V2. Since we found V2, so therefore Q is equal to A2 pi by 4 into D2 square into V2. So substitute all the values. We know the we found the final answer. That means 0.03275 meter cube per second, since we substituted all the values in terms of meter and second only. So 0.03275 meter cube per second is the answer. Okay, so but we have to write in terms of liters per second. Discharge always in terms of liters per second. So into 1000, multiply this value into 1000. 1 meter cube is equal to how much liters? 1000 liters. So 1000 means finally we got 32.75 liters per second. This is the final answer. So this problem is very, very important problem, because in this problem there are two parameters V1, V2. Based on the hydraulic gradient, we found V2. After that, finally, we can easily find the discharge. Okay, so this is also one important problem. Okay, so let us see the next problem. The rate of flow of water through a horizontal pipe is 0.25 meter cube per second. So rate of flow discharge given. Diameter of the pipe, which is 200 mm, is suddenly enlarged to 400 mm. So 200 to 400 mm. The pressure intensity in the smaller pipe is 11.772 Newton per centimeter square. Okay, so here they given the pressure intensity at the smaller diameter pipe. Okay, so what they asking? Loss of weight due to sudden enlargement. Next, pressure intensity in larger pipe and power loss due to enlargement. Okay, so there are three things they are asking. So let us see one by one. So first write the given data. Discharge is 0.25 meter cube per second, and the dia of smaller pipe D1 is equal to 0.2 meter. Okay. So next, area. Area is equal to A1 equal to pi by 4 into 0.2 square, which is equal to 0.03141 meter square. And dia of larger pipe D2 is equal to 0.4 meter. So D2 is equal to pi by 4 into 0.4 square. It is 0.12566 meter square. So in this problem, they given pressure at the first section. Okay, so therefore P1 is equal to 11.772 Newton per centimeter square. If you convert it into meter square, means you multiply by 10 power 4. Okay, so now velocity V1 is equal to Q divided by A1. So what is discharge? Discharge also given, it is 0.25 divided by A1. A1 is 0.03141. So velocity formula, discharge divided by area. Here two section is there. We have to find the velocity at two sections. Okay, so Q divided by A1, we got 7.96, and the corresponding V2 Q divided by A2, it is 1.9. So answer for the first question, loss of weight due to sudden enlargement. We know the formula H is equal to V1 minus V2 the whole square divided by 2G. So 7.96 minus 1.99 square divided by 2 into 9.81. So it is 1.816 meter. So this is the loss of weight due to sudden enlargement. Okay. So what is the pressure at section 2? So let the pressure intensity in the larger pipe P2. Now applying Bernoulli's equation before and after the sudden enlargement. Okay, so pressure formula is available in Bernoulli's equation. Okay, so write the Bernoulli's equation: V1 by rho g plus V1 square by 2g plus Z1, which is equal to V2 by rho g plus V2 square by 2g plus Z2 plus HE. HE is the, we already found here. You can see loss of weight due to sudden enlargement. Okay. So here Z1 equal to Z2. Z1 equal to Z2. So P1 by rho G plus V1 square by 2G, which is equal to P2 by rho G plus V2 square by 2G plus HE. Okay. So both pipes are horizontal. So Z1 equal to Z2 get cancelled. Okay. So what we need only P2 term. Okay, we need only P2. Okay. So keep this P2 here. Only right side. So all other terms are goes to left side, means P2 by rho G equal to P1 by rho G plus V1 square by 2G minus V2 square by 2G minus HE. Okay, so therefore 11.7 P1 equal to 11.772 into 10 power 4 divided by rho G. Rho is 1000 and G is 9.81 plus V1 is 7.96 square divided by 2 into 9.81 minus V2 1.99 square divided by 2 into 9.81. Okay, so minus HE is equal to, what is HE? Previously we already found HE. It is 1.816. Okay, so finally we got an answer. That means pressure head. That means P2 by rho G. Okay, is equal to 13.21 meter of water. So therefore, from this P2 is equal to 13.21 into rho G. So 13.21 into rho is 1000 and G is 9.81 Newton per meter square. So multiply by P2, sorry, that is 13.21 into rho G. Here, because denominator rho G is there. Okay. So finally, we got P2 is equal to 12.96 Newton per centimeter square. So initially, it will come Newton per meter square. So you multiply by 10 power minus 4 means we got in terms of Newton per centimeter square. So finally, power loss due to sudden enlargement. This is the third question they are asking. So power loss is equal to rho G Q into HE. Rho G Q into HE. So rho is 1000, Q, G 9.81 and Q discharge is 0.25 is given in the question and HE is 1.816. 1.816 divided by 1000. We got 4.453 kilowatts. So the unit of power is kilowatts. Okay. So I hope all of you understand the problems. So we will discuss some other problems in the next class. Okay, students. Thank you. If you have any doubt, you can ask me.